Hello. My name is Humphrey Solomon Jr. Welcome to my channel. Our today's video presentation is about circles in conic sections. Before we continue, please watch my other tutorials and please subscribe to my channel, thank you so much. In conic sections, a circle is the intersection of the plane and the cone, if, and only if, the plane is perpendicular to the axis of rotation. In analytic geometry, a circle is the set of points on a plane, equidistant from a fixed point. The fixed point is the center. The distance from the center to any point P of the circle is called the radius of the circle. If we let capital C be the center of the circle, with coordinates hk, and let r be the length of the radius, the equation of the circle in standard form is equal to the equation below. And the equation of the circle in general form is equal to the equation below. For example, given the center of the circle at 2, 3, and the radius at 4, write the equation of the circle in general form. We start with the standard form of equation of a circle, and substitute the value of the center, 2, 3, and the value of the radius, 4. And then, we will expand the quantities of x and y. Note that, the power of the quantity which is 2, is not distributive here. We should multiply the quantity, x minus 2, by the same quantity, x minus 2. After we expand the quantities of x and y, we need to rearrange the terms. We will put x squared first, plus y squared, minus 4x, minus 6y, plus 4, plus 9, minus 16. Simplifying the sum of 4, 9 and negative 16, our final answer is, x squared plus y squared minus 4x minus 6y minus 3 equals 0. Now, if the center of the circle is at the origin, then the equation of the circle in standard form is, x squared plus y squared, equals r squared. And the general form is, x squared plus y squared plus f, equals 0. Let's practice finding the coordinates of the center, and the length of the radius of a circle. Number 1, x squared plus y squared, equals 9. The center is 0, 0, and the radius is 3. Number 2, x squared plus y squared, equals 12. The center is 0, 0, and the radius is 2 square root of 3. Number 3, the quantity x minus 5 squared plus the quantity y minus 2 squared, equals 25. The center is 5, 2, and the radius is 5. Notice the sign of 5 and 2 were changed in writing the center hk. Number 4, the quantity x plus 2 squared plus the quantity y minus 3 squared, equals 16. The center is negative 2, 3, and the radius is 4. Number 5, 6x squared plus 6y squared, equals 24. We have to divide both sides by 6, to get x squared plus y squared, equals 4. The center is 0, 0, and the radius is 2. In the same way, number 6 needs to be divided by 4 on both sides. We now have, x squared plus y squared, equals 8. The center is 0, 0, and the radius is 2 square root of 2. And now, number 7. X squared plus y squared plus 6x minus 4y minus 12, equals 0. This is in general form, and we need to write this first into standard form. We need to transpose the negative 12 to the right side to become positive 12. Next is to group the terms with x and the terms with y. We can now use completing the square for the x and y quantities. Here, we divide the coefficient of x by 2, and then we square it. We will get plus 9. Then, we divide the coefficient of y by 2, and then we square it, we will get plus 4. Don't forget to add the same numbers also to the right side. This is to make sure that both sides will remain equal. Now that we have perfect squares for the x and y quantities, we now have the standard form of equation for the circle. From here we can get that, the center is negative 3, 2, and the radius is 5. Now, let me show you a short method of finding the center and the radius of the circle. From the standard equation of a circle, center at hk, we have the quantity x minus h squared plus the quantity y minus k squared, equals r squared. Expanding the quantities of x and y, we will get this equation below. Next, rearranging the terms, we will get this equation. And then, recall the equation of the circle in general for, we have. If we will observe carefully, from here, we can see that d is equal to negative 2h, and e is equal to negative 2k, and f is equal to h squared, plus k squared, minus r squared. From there, we can have h equals negative d over 2, k equals negative e over 2, and r squared equals h squared plus k squared minus f. Now, let's try this using an example. Find the coordinates of the center of the circle and the length of the radius. Here, we have d equals 6, e equals negative 4, and f equals negative 12. Solving for h we have h equals negative 3. Solving for k we have k equals 2. Solving for r we have r equals 5. Our answer, the center is negative 3, 2, and r equals 5. Next lesson, graphing equations of circles. Graph the circle whose equation is x squared plus y squared equals 25. Our first step is to plot the center on the xy plane. Next, is to use the length of the radius, 5, to plot 4 points from the center of the circle. Finally, we can draw the circle using these 4 points. Next example in graphing equations of circles. Graph the circle whose equation is the quantity x minus 1 squared plus the quantity y plus 2 squared equals 9. Our first step is to plot the center on the xy plane, 1, negative 2. Next, is to use the length of the radius, 3, to plot 4 points from the center of the circle. Finally, we can draw the circle using these 4 points. After learning how to graph, we will now find the equations of a circle with given conditions. Example number 1. Find the equation of the circle, with the center at 2, negative 3, and a radius of 5. With the given values for the center and the radius, we just need to substitute these values to the standard form of equation for the circle. We now have the answer. The quantity x minus 2 squared plus the quantity y plus 3 squared equals 25. It's that easy. Example number 2. Find the equation of the circle, with the center at negative 5, 0, and a diameter of 14. With the given values for the center, and half of the diameter is the radius, we just need to substitute these values to the standard form of equation for the circle. We now have the answer. The quantity x plus 5 squared plus y squared equals 49. Example number 3, find the equation of the circle in standard form, with the center at 2, 1, and a point on the circle with coordinates negative 2, 5. Since we were not given the value of r, we will use the given center and point to find the value of r. Let's put the value of hk in the equation. And then, substitute the x and y from the point P. Simplifying, we have the square of negative 4 plus 4 squared. That is 16 plus 16. So r squared is 32. Now that we have r squared, we can put back the center and r squared in the standard form of equation for the circle, and now we write our answer, the quantity x minus 2 squared plus the quantity y minus 1 squared, equals 32. Example number 4, find the equation of the circle in standard form, with the endpoints of the diameter at 3, 1, and 11, 9. I will show the graph of the circle on the right. The center is the midpoint of 3, 1 and 11, 9. So our center is at 7, 5. Now that we have the center, we will now choose one point from the given endpoints of the diameter. We now have the point P, 3, 1. We will use these to find the radius using the standard form of equation for circles. We substitute the values of hk from the center, and xy from point P. And then, we will simplify. To get, r squared is equal to 32. Now that we have the center, and also the r squared, we will use the standard form of equation for circles again. Substitute the values of hk from the center, and r squared. Our answer is, the quantity x minus 7 squared, plus the quantity y minus 5 squared, equals 32. Example number 5, find the equation of the circle that passes through 3 points, 5, 0, 1, 4, and 11, 6. Here, we will use systems of linear equations. We will substitute the x and y values from each point that the circle passed through, to the general form of equation for circles. For the first point, 5, 0. If we substitute the x and y values here, we will have equation 1, in standard form. For the second point, 1, 4. If we substitute the x and y values here, we will have equation 2, in standard form. For the third point, 11, 6. If we substitute the x and y values here, we will have equation 3, in standard form. Now that we have the three equations for the system, we can use the Casio-Clausewitz to find the values of d, e and f. In equation mode, we will select simultaneous equations. Then, input the number of unknowns, select 3. We are now ready to input the numerical coefficients and constants for each of the equations. After we input the coefficients and constants carefully, we will get x equals negative 12. This value of x corresponds to the value of d. And the value of y equals negative 10. This value of y corresponds to the value of e. Then, the value of z equals 35. This value of z corresponds to the value of f. We will now use these values of d, e and f in the general form of equation for circles. We now have. From here we can get h, k, and r squared. H is equal to negative 12 divided by negative 2, h equals 6. K is equal to negative 10 divided by negative 2, k equals 5. R squared is equal to 6 squared plus 5 squared minus 35, r squared equals 26. Now that we have hk and r squared, we can now write our equation in standard form. The quantity x minus 6 squared, plus the quantity y minus 5 squared, is equal to 26. I hope you learned something about circles in conic sections. Thanks for watching this video. Don't forget to hit the like, share, and subscribe buttons below. Also, click the bell icon to get notified when I upload my next videos. Always remember, sharing is caring. Have a